Okay. Yeah. Good morning, everyone. So in the last class, we discussed about hypothesis testing. Uh, we discussed about what are the steps we need to follow while testing the hypothesis. So in that context, we discussed that in hypothesis, we have two types of hypothesis. One is null hypothesis. Another one is alternative hypothesis. And null hypothesis says there is no significant difference, or there is no significant relationship between two or more variables. And alternative hypothesis is exactly opposite to the null hypothesis, and which says there is a relationship between, or there is a significant difference between two or more variable. The main task of hypothesis testing is to accept or reject a null hypothesis or alternative hypothesis. We have to decide which hypothesis we have to keep in our research, whether we are going to keep a null hypothesis or we are going to keep alternative hypothesis. So when we discussing about hypothesis testing procedure, the first step we need to state null hypothesis and alternative hypothesis. We have to write what exactly null hypothesis and what exactly alternative hypothesis. So that is the first step we need to follow. And then after writing or after stating null hypothesis and alternative hypothesis, then the second step is to decide the significance level. We have to decide what is the significance level or what is the confidence level in our result. In that, we discussed that significance level is nothing but we are trying to minimize a type 1 error. So there are two types of error. One is type 1 error and other one is type 2 error. So we also discussed about what do you mean by type 1 error and when it occurs, and what do you mean by type 2 error and when it occurs. See, type 1 error means we are uh, rejecting a null hypothesis in when it is actually true. We are rejecting null hypothesis when actually it is true. So that is type 1 error. And type 2 error means we are accepting null hypothesis in actually it is wrong. So that is two types of error. So in research, it is what accept, it is okay to accept a type 2 error, but it is very dangerous to accept type 1 error. So therefore, we are always try to reduce our type 1 error. So the significance level is nothing but what is the probability of conducting type 1 error. What is the chances of doing type 1 error? We have to keep that type 1 error always less. Therefore, in research, either we keep it as 1% or we keep it as a 5%, because it is very difficult to say that our result is 100% correct. It is very difficult in statistics also, in mathematics also. It is always very difficult to say that our result is 100% correct. So there may be a 1% error. So we always says in our result either 99% or 95%. We are confident in our result. So that is called a type probability of error or significance level. So in second step, after deciding hypothesis, we need to decide what is the level of significance level. We denote as a alpha. We denote it as a alpha. So either it 5% or 1%. We have to decide. So after deciding significance level, next step is we have to collect the data and we have to choose an appropriate statistical tools. that is depending upon the various conditions. So we have to see all those conditions, whether it is fulfilled, then we have to go for respective statistical tools, whatever. After that, after selecting a statistical tools, the next step is to, we have to decide, that we call it as a decision rules. So each statistical tools has its own what decision rules are there, but there are some basic criteria which we look for to accept or reject null hypothesis. So what is the basic decision rules in accepting and rejecting null hypothesis? See, we discussed that there are two values in hypothesis testing. The first value is a calculated value. The first value is calculated value. Other one is a table value. We have to see what is the calculated value and what is the table value. Then we have to compare it. We have to compare both table value and calculated value. If calculated value is less than what table value, then accept null hypothesis. If calculated value is more than table value, then reject null hypothesis. So when you are accepting null hypothesis, you are rejecting alternative hypothesis. When you are rejecting null hypothesis, you should accept alternative hypothesis. So that is the criteria. And yeah, so when we are doing hypothesis testing by hand, that is working in hand, then we have to compare calculated value and table value. If you are doing hypothesis testing in any statistical software, then we have to check the p-value. It generate a p-value. So if the p-value is less than 0.01, then we have to accept alternative hypothesis, then reject null hypothesis. If the p-value is more than 0.01 or 0.05, then have to reject null hypothesis and accept alternative hypothesis, like that. So basically, if p-value is less than 0.01, when you keep significance level 1%, at that time, we have to state that there is a significant difference if the p-value is less than 0.01. If it is more than 0.05, then we have said that there is no significant difference in, or there is no significant relationship between the variables. So that is the way of accepting and rejecting null hypothesis. So after that, after in hypothesis testing also, the one more concept is that in hypothesis testing, we have some of the concepts we have to understand. That is, one is one-tailed test and two-tailed test. In hypothesis testing, we come across the concept called one-tailed test and two-tailed test. Then what do you mean by one-tailed test and two-tailed test? See, this one-tailed test and two-tailed test, you can easily identify by looking at the hypothesis itself. If you read the hypothesis, you can say whether it is a one-tailed test and two-tailed test. How? See, one-tailed test always have one end. It is always one end. One end means either it says less than or it says more than. But in two-tailed test, it has both end. Both end means right hand and left hand. See, you can see this table here or this chart. See, what do you mean by one-tail test? See, this one first chart explains about one-tail test. See here, the rejection area. This is the rejection area. We keep significance level 5%. 5%. So this is 95% area is the acceptance area, and this is the 5% area is rejection area. If the calculated value is lies, then in this rejection area, then we have to reject null hypothesis. If the calculated value lies in the acceptance area, then we have to accept null hypothesis. See here, in this chart or in this diagram, we can say that, see that here only one side there is a rejection area, that is left side. Only left side we have rejection area. Therefore, it is called one tail test. If you look at the second figure, here we can see there are two rejection area both the side, in right hand side and in left hand side we can see the rejection area. Here the probability or the probability of 0.05 and here also 0.05. Simple. Here, researcher keeps 10% significance level. 10% significance. When you keep 10% significance level, it goes 0.05 a right side and 0.05 left side. Both the side you have to keep equal proportion as a rejection area. If you keep a significance level 1%, 5%, if you keep significance level 5%, then 0.025 on the right side and 0.025 on the left side. So you keep a rejection area in the equal proportion. If you keep significance level 1%, then 0.005 at this side and 0.005 at this side. You have to distribute rejection area in equal proportion. So when we identify it is a one-tail test or two-tailed test, just by if you look at the hypothesis, a minute, and if I look at the hypothesis, if hypothesis says mu means population mean average, mu is equal to 25. Consider mu is equal to 25. So that is alternative hypothesis. What is null hypothesis? See, null hypothesis says we write as a H naught. H naught is equal to mu is not equal to 25. Mu is not equal to 25. And alternative hypothesis says alternative hypothesis is equal to mu is equal to 25. So what does mean? Consider this one is whatever the average scores of students in the first semester. What is the average scores of the students? We need to find out whether average score of the student is equal to 25. Is equal to 25. So that is working hypothesis. So null hypothesis says average scores of the student is not equal to 25. Null hypothesis says average score of the student is not equal to 25, but alternative hypothesis says is equal to 25. We need to test a hypothesis by using any statistical tools. After that statistical test, we have to accept or reject null hypothesis. If we reject null hypothesis, then we have to accept alternative hypothesis. For example, consider by hypothesis testing, we found that calculated value is more than table value. So when calculated value is more than table value, then we have to reject null hypothesis. We have to accept alternative hypothesis. So what does mean? How we should write our interpretation? In interpretation, we should write as per hypothesis testing, the calculated value. We have to write what exactly the calculated value is more than table value. Again, what exactly the table value. So therefore, we are rejecting null hypothesis and accepting alternative hypothesis. And it concludes that the average scores obtained by the student is equal to 25. So that is the way of writing interpretation for hypothesis. See here, when you look at the hypothesis, it says equal to 25 and not equal to 25. So when hypothesis says equal, when hypothesis says equal, so that means we are testing both the sides of the rejection area or distribution. So when we have equal and not equal, then it is called a two-tailed test. We are testing both the side. So there is no significant difference between the values. So we are checking both the side, both right hand side and left hand side. And how what is when we can identify when that is one tail test or not. See, one tail test basically we write like null hypothesis. If we consider same example, null hypothesis says null hypothesis is equal to mu is more than 25. So we use less or more than symbol when we use not null hypothesis. This is alternative hypothesis. So alternative hypothesis says either more than or less than. So here null hypothesis is mu is not more than 25. Is not more than 25. Alternative hypothesis says the mu is more than 25. So if you write this as a statement, it says the average score of the student, null hypothesis says average score of the student is more than 25. It says null hypothesis, alternative hypothesis says the average score of the student is more than 25, and null hypothesis says is not more than 25. We are not checking whether it is less than 25. We are checking only whether it is more than 25. So in one tail test, we are checking only one side of the distribution. So other example is it may be mu is less than 25. So that is, these are the one tail test. When you are using or when you are testing one side of the distribution, that is either less than or more than, then we are call it as a one tail test. See here, if the rejection area or if your null or if your alternative hypothesis is less than, the population mean is less than 25. If you use less than, then it comes left hand side of rejection area. Left hand side of rejection area. If you are only testing less than, then it comes left side. If you are testing more than symbol, then it comes this side. It comes this side, only this side only, right hand side only. That is 0.05. If you are testing hypothesis by using equal and not equal, then it appears in the both the side, both right hand side and left hand side. So that is the basically difference between one tail test and two tailed test. And yeah, of course, for why it is very important is while doing a statistical test for hypothesis, first the table value will be differ. The table value will be differ for one tail test and two tail test. The calculation of calculated value will be same. The procedure for calculation of calculated value will be the same, but the table value will be differ. So therefore, you need to very careful while checking it the table value. The first thing you need to identify whether it is one tail test or two tail test. If you look at the distribution table. So there are different values for one-tailed test and two-tailed test. If you not follow that, then your decision rules will be wrong. So that is a basic criteria in one-tailed test and two-tailed test. Next concept here, as we discussed in statistical tools, we have a parametric test and non-parametric test. So what do you mean by parametric test? See, a parametric test is nothing but we are making some assumption about population parameter. We assume some of the parameters like mean or standard deviation of the population before going for a statistical test. See, some of these tests requires the population mean or the population standard deviation. So we assume, or sometimes we get what exactly the mean and standard deviation of the population. At that time we can take other, or else we can assume what is the population mean and standard deviation. So if you assume the population parameter, then it is called parametric test. If you are not assuming any if you're not assuming anything, if you want directly if you go directly calculation, then it is called a non-parametric test. See, look at what is the difference between parametric test and non-parametric test. See, here some basic difference between parametric test and non-parametric test are given. The first one is the meaning. Meanings says that a parametric test is a statistical test in which a specific assumption are made about the population parameter is known as a parametric test. Specific assumption means we assume that population mean is something. We assume that population standard deviation is something. We assume that the data is normally distributed. So that is the some of the assumption we made for parametric test. And what do you mean by non-parametric test? A non-parametric test is a test used in case of non-metric independent variables is called non-parametric test. So some of the data we cannot make an assumption. So at that time, we have to go without making an assumption. So that test is called non-parametric test. And what is the basis for test of statistic in parametric test? So that is the distribution. Distribution, a very important criteria for choosing a parametric test. And here arbitrary. Arbitrary means we are, see, in parametric test used when our data is in variable nature. Variable nature means we like the values are directly getting in the form of numbers. In the form of numbers, then we can go for parametric test like average height of the students, scores of the students, or stock market value, sensex value. So these variables we get in the form of number, and which exactly represent the values. If sensex value or 30,000 means it exactly 30,000. If the average height if the heights of the student is 6.5, it exactly represents the value. But in non-parametric test, arbitrary means we are attaching the values for variables. For example, gender. In gender, we assign the values for male 1 and for female 2. Like that. This value does not represent exact value. We are just giving, especially in the case of nominal data. In the nominal data is nothing but we just by forgetting the, or we are differentiating the variables from one another, categorizing the variables. So male, nationality, gender, nationality, and designations, like that. So these are some of the example for arbitrary data. Arbitrary means you are just assigning number for differentiating. Then measurement of scale. See here, the measurement of scales are given like interval and ratio scale. In parametric test, interval and ratio. Interval means 25,000 to 30,000. If annual income 25,000 to or 30,000 or 30,000, that means that exactly. So that value represent exactly the variables. A ratio, you know what you mean by ratio. Ratio means exact value, like 25, 30, like that. But nominal and ordinal, nominal is, as I said, nominal for just for the namesake, you're giving the numbers, male and female, and ordinal data also, you're assigning the some variables in order, the first order, second order, and third order, or first rank, second rank, third rank, like that. So when your data is in the form of interval or ratio, then you have to go for parametric test. And if your data in the form of nominal and ordinal type, then you can go for non-parametric test. Then what measurement of central tendency we have to use for parametric and non-parametric test. In the last class, in the previous class, we discussed like when we have to use mean and when you have to use median and mode. The mean are basically used when your data is in the form of interval or ratio, and median are used when the data is in the form of nominal or ordinal. And next one is information about population is completely new. We know about what exactly the population mean and what exactly the population deviation, size of the population. So all those information, if you know about the population details, then you can go for parametric test. If the details are not available, then we have to go for non-parametric test. And applicability also, it applicable only for variables. It applicable only for variables, but non-parametric applicable both for variables and attributes. Variables means in the form of numbers, and attributes you are assigning the numbers just for namesake. So if your data completely variable, then you can go for a parametric test. And if your data is variable, sometime what happens, one dependent variables in the form of numbers, but independent variables in the form of category or nominal data. So at that time, we have to go for a non-parametric test. In correlation test, for correlation, if it is like if these all above conditions are satisfied, then you have to go for Pearson correlation test. And if it is non-parametric, then Spearman's rank correlation test. So these are some basic difference between parametric test and non-parametric test. So the next concept is in the hypothesis testing procedure. As I said, the choosing appropriate statistical tools is an important task, because it is not possible to test or any statistical tools for any type of data. So there are some criteria while choosing an correct statistical tools or statistical test. So actually this concept is what advanced concept. It is not easy to understand, because in our syllabus we are going to discuss only some of the basic statistical tools. So there are n number of statistical tools are there. So out of those statistical tools, we have to choose which is the proper statistical tools for your respective data. So that depends upon the various conditions are there. I hope this is visible. See, the flow chart for selecting commonly used statistical data. See here, parametric assumption. What are some parametric assumptions are given? The first one is independent and unbiased samples. When you are selecting the sample, it should be independent. Independent means the unit in the first sample should not be unit in the second sample. We should not take same samples for hypothesis testing. So it should be independent from one another. It should not be there should not be a relationship between samples. So that is called independent samples. And data should normally distributed. Normally distributed means uh, uh, both the side, the mean value. When you look at when you draw the chart, it should be come like a bell-shaped curve. Bell-shaped curve we discussed in previous class. It should be a bell-shaped curve. Both the side 50-50%. So that is called normally distribution. And equal variance. The variance between the variables, variance or distribution should be equal. So there is a test called Levin's test. Levin's tests are used for testing the variance. By looking at the Levin's test value, we can say whether there is a equal variance between the variables or there is no equal variance. If there is equal variance, then we have to go for parametric test. If the data is normally distributed and if it is independent, then we can go for parametric test. So after that, once you decided whether it is parametric and non-parametric, then how to see what the type of data. So whether it is continuous data or discrete or categorical data. Continuous data is nothing but you are getting the exact value, the scores obtained by the students, or height of the students, or sensex value, any value. It is in the continuous form, 7.5, 7.6, 7.8, 7.10, like that. So that is called continuous data. If it is a discrete or categorical, discrete means either you're grouping the variables like male and females, categorical data, then see the division. If it is continuous, then you have, if it is discrete or categorical data, then you have to either go for chi-square test and one and two samples. So if it is discrete and categorical, like if your hypothesis says there is no significant difference between male and female in the scores obtained by the student. So there is two variables, that is male and females, which is totally independent, but categorical data, male and female data, and I want to know whether there is significant difference or association, then I have to use for chi-square test. Then type of data, if it is continuous data, then I have to ask again one more question, that what type of question, whether you want to know the relationship between the variables or you want to know the significant difference between the variable. If you want to know the relationship between the two variables, then again you have to ask one more question. Do you have two independent variables? Whether it is exactly the difference true independent variables. Then if it is yes, then we have to go for regression analysis. If it is no, then correlation analysis. Again, in correlation analysis, as I said, there are two correlation analysis, one Pearson's correlation and Spearman's rank correlation. So so that is depending upon whether it is parametric or non-parametric test. So if your purpose of hypothesis is to know significant difference between the variable, then differences between what? Test for equal variance. If it is variance, then Fmax test, Brown and Smith test, and Bartlett's test are there. If it is significant difference between the mean values, then how many treatment groups? If it is two groups, means only male and female. Then if parametric assumptions are satisfied, then these are the tests are available. If it is not, then see again, if parametric assumptions are satisfied, no. The answer is no. A data transform work. That means if they see in the parametric test, one of the assumption is it should be a normally distributed. If the data is not normally distributed, we can transform the values, and we can transform the values into normally distributed. It, it, it won't work always, but it works sometime. So if it works, then you can go for a parametric test. If it won't work, if it not work, then you can go for non-parametric test. These are the non-parametric tests for significant difference. Then if it is more than two groups, again, parametric assumption are satisfied. If it is more than, then ANOVA. If it is parametric assumption are not satisfied, then transform also not satisfied, then non-parametric Kruskal balance test, and these are the tests are there. Yeah. See, this website, there is one website called STAT. Yeah, Institute for Digital Research and Education and Statistical Consulting. I think this website is a very what a proper way to identify the statistical tools and very useful. I think it is very useful website to identify the statistical tools. See, you don't worry about in the examination. In the examination, there is no complex in the selection of statistical tools, because in the examination they directly used as a chi-square test and find out the result, or use a t-test and find out the result. So there in examination purpose, there is no difficulties in the identification. I'm explaining this for you are in practical. If you are doing any research paper, or if you are doing any dissertation or project, then it will be useful. I'll stop here. We'll start our